Hey there, today I'm going to cover iterators in Python and the Itertools standard library. Actually, a while ago somebody in the audience mentioned that they really like these deeper dives into the Python standard library. I think there's a couple of really cool packages that I want to dive into, so I thought, you know what? Let's make this a thing. So, welcome to this new series on the Python standard library and a deep dive into the possibilities without having to install any third-party modules. Even got a coffee for the occasion. This is actually already take 7, so I'm like, this is a video about Itertools. No, just kidding. I can deal with caffeine pretty efficiently, so I normally don't have to worry about that. Anyway, knowledge about the Python standard library is actually really useful. If you're writing your own code, it can often provide you with certain shortcuts to make things easier, but it's also helpful if you're reviewing somebody else's code. If you want to become better at reviewing somebody else's code and giving more useful feedback and also being able to do that efficiently, I've got a free workshop for you. You can get access by going to arjan.codes/diagnosis. And this workshop is like 30-40 minutes of me diving into existing code bases and doing a review and show you how to detect issues in code efficiently and effectively. It's really practical, to the point you can just take those ideas, apply it immediately to your own code base. So arjan.codes/diagnosis to get access. The link is also in the description of this video. So what is an iterator? Well, it's an object that's used to traverse through some sequence of items. And this process of traversal is called iteration. In Python, an iterator is an object that implements the iterator protocol. And that protocol defines two methods, iter and next, both dunder methods. Iterators in Python are basically everywhere. You've probably used them already lots of times while not even realizing that you were using iterators. They're elegantly implemented within for loops, list comprehensions, generators, and more. Basically, they're all over the language, but they're hidden in plain sight. Let's take a look at some examples. What I have here is a sequence of countries. In this case, countries is a tuple of strings. And what I can do now is there's basically two functions that are important. There's the iter function and there's the next function. So first I can get an iterator as follows. Like so. So this gives me an iterator over the sequence of countries. And now what I can do is print the next element in the country sequence by calling next on the iterator. And when I run this, this is what we get. Now I can call next a number of times. For example, there's in total 6 countries in this sequence, so I can call this 6 times to print out all the countries in the sequence. Then this is what we get. If you do it one more time, then next is actually going to raise a stop iteration error. This is what you're seeing here. So if you want to go over all the elements in the sequence and then stopping at the end, you can basically use a while loop for that. So let me delete this. And then we're going to say while true, I'm going to try getting a country using next, like so. And if we catch a stop iteration error, I'm going to break out of the while loop. Else, I'm going to print the country. So when I run this, this simply prints out all the countries in the sequence until we reach the last one, which is Greece. Now, of course, this isn't normally how you would do it in Python. I just want to show you how it works with the stop iteration error catching and so on. There's a much shorter way to do it, which is using a for loop, and that actually internally more or less does this. And then I don't even need to create an iterator. The for loop already does this for me. And this gives, obviously, exactly the same result. So the while loop I just showed you before, don't use that, simply use a for loop like this. You may have heard two terms being used in the Python world related to iterators, which is iterators and iterables. And those are actually not the same thing. An iterable is an object that can provide you with an iterator. And an iterator is an iterable that also has a next dunder method. So they are related, but they're not the same thing. Now, sequences like lists, tuples, dictionaries, etc. are all examples of iterables, and they allow you to get an iterator from them, which is what I've just shown you in this example. Initially, I thought the way that iterables and iterators were organized in Python a bit strange. I mean, why would an iterator have an iter method? Like the country iterator, for example, it itself has an iterator method, and that's called by the iter function in turn. And what it actually does in this case is it returns exactly the same iterator. So for example, what I can do is I can print next of the country iterator, so that's going to print Germany, right? But then if I create an iter copy, which is the iterator of country iterator, and then I print the next one from this copy, you'll see that this is going to print France, because it's actually the same iterator. So that's what you see here, Germany, then France. So I could just as well have called here next country iter, it would have been the same thing. And that's what happens when you call an iter function on an iterator. But if you call iter on the sequence, which is the iterable, the behavior is different. So for example, I can print here next using this iterator, but now I'm creating a new iterator from the sequence. And that's actually going to be another separate iterator. So now this is going to print Germany twice. Though I don't find this completely logical, the main thing you can do with this is basically restart an iterator or have the possibility to iterate a sequence at the same time in various places in the sequence. So in that sense, it's kind of useful, but it's good to know the difference between iterables, which allow you to restart an iterator, and iterators, which simply just give back themselves when you call iter on them. Okay, a couple of other things you can do with iterators that are actually pretty cool. One is that you can call iter, the iter function, with a function and a sentinel value. And what that does is it's going to call the function until the function returns the sentinel value. And that's very useful, for example, if you want to go through, let's say, a text file and you want to read lines of text until you reach the end of the text file. So what I have here is I have a file called countries.txt, which contains the same countries as I have in my main file. But then what I can do is, let me replace this. I can simply use a for loop, and then I can use with to open the file countries dot, I need to type correctly, .txt, like so. And then for line in, and now I can use actually an iterator, f.readline, file.readline. So I'm going to use the readline function until it reaches the sentinel value of the empty string, which is the end of the file. And now I can simply print each of these lines. In order to print it nicely, I can tell the print statement to end it with the empty string and not with a new line. And then this is what we get. It simply prints all of the countries like we had before. So this is useful if you want to call a function a number of times in a sequence until you reach some sort of value. Another nice thing that you can do with iterators is that they provide you a mechanism of abstraction. So here I have an example that shows you how this works. I have a simple class called lineItem. That's a data class. It's frozen, so it's basically read-only. It has price and a quantity and a total price method that simply multiplies the two. Now, I've used this example before in other videos, so you may recognize it, but it's just to keep it simple. There's also a print totals function that basically takes a number of items. So here you see I'm using the type iterable. So that's basically anything that's iterable and that contains line items. And that's going to use a for loop for item and items, and it's going to print the total price. And then in my main function, I have my line items list, which contains a couple of line items. It doesn't really matter what the values are. And then I'm calling print total. When I run this, we simply get a number of totals printed here on the screen. But what's interesting is because print totals now relies on the type being an iterable, I can basically replace this by any type of sequence. So instead of a list, I could also decide to use a tuple, like so. And when I run this now, obviously, I'm going to get exactly the same result because I'm simply iterating through the sequence. But print totals doesn't care about the specific type of sequence that items is. And that means we've now introduced a level of abstraction. The only thing that print totals needs to know is that it's some iterable sequence, and it just uses a for loop to traverse that sequence. We don't really care what the data structure is exactly, and that's really nice. By the way, it is important for the data class to be frozen in this example, because some data structures, like the set, for example, it relies on being able to find the element quickly using a hashing function. So when I run this, this works without issues. But if I remove the frozen indicator here, and then I try to run this again, and you see we're going to get an error that line item is unhashable. If you use frozen, this problem is solved. What you can also do is add your own hash function to the line item, and then that's also perfectly fine. By the way, if you're enjoying this video so far, give it a like. It helps others on YouTube find the content as well. Iterators are in principle something that you can build yourself using your own classes with iter and next dunder methods. So here you see an example of that. It's really simple. We have a class called infinite number iterator, and that has an iter dunder method and it has a next dunder method. It has only one instant variable, the number, and what it does for next, it simply increases the number by 1 and then returns that number. So that just goes through the numbers and it does it infinitely. So this also shows that iterators don't have to be finite. They can in principle be infinite if you want to have that kind of behavior. What's interesting here is that the iter dunder method simply returns the iterator, like what happens if you get an iterator from a list and then ask that iterator to provide an iterator. Is that confusing? It's probably getting pretty confusing. Sorry about that. But what's nice is that since I'm using Python 3.11, I can use the self type here. So another useful case of the self type. Here I have a variety of this, which I'm simply calling a number iterator, and that not only has a number like this one, but it also has a maximum. And then, well, iter is the same, but in the next dunder method, I check whether the number is above the maximum. If it is, I'm going to raise a stop iteration error. Otherwise, I simply call number plus 1 and return self.number. And then in my main function here, I'm simply calling number on the number iterator and printing that number. And of course, we see it does that until it reaches the maximum that we indicated here as a parameter. So this is in the core how an iterator works under the hood, and you can build your own iterators this way. And then it integrates nicely with things like for loops, etc. in Python. If you want to take iterators to the next level, you should take a look at the Itertools package in Python. It's included in the standard library and it has some really cool features. I'm going to show you a couple of them now. Basically what Itertools does is that it provides a sort of algebra of iterators that you can combine in various ways. In that sense, it builds on functional programming principles like higher order functions. I did a video about functional programming in Python a while ago. If you want to learn more about that, check out this video at the top. Now, in order to get started with Itertools, the only thing we need to do is simply import it at the top. And I'm going to show you a few examples of what you can do with this. So this ranges from very basic things to pretty powerful things. And you can combine these iterators in all kinds of different ways in order to result in complex behavior. And where iterators really shine is by replacing loops with combinations of iterators. For example, let's say you want to print out totals and you have a list of prices and a list of quantities. Well, you could write a for loop to do that sort of naively, but you can also use the star map function provided with a multiplication function and a tuple of iterables, and that's also going to work. I'll show you an example of that in a minute, but let's start with something a bit more simple. I'm going to start with a simple example of using an iterator to do counting. So I'll use a for loop, and then I'll use itertools.count. And I can provide it with an integer, which is a starting value. So let's say that's 10. I'm going to print I, and then if I equals 15, I'm going to break out of the for loop. When I run this, then this is what we get. Very basic. Another thing we can do is repeating. And repeat gets an object, and that's going to return that object a number of times. So for example, I can provide it with an object of type integer, let's say 10, and I want it to return that integer 4 times. So this is no longer needed, of course, and let's add a column. So when I run this, we get 10 printed 4 times. So simply repeating. Another thing you can do is accumulate. And accumulate, you can provide it with a range. Let's say range from 1 until 11. And then we run this, and you see it's going to accumulate these numbers. 1 plus 2 plus 3 plus 4, etc., until 11. And there's way more functions. For example, let's say we have a list of items. A, B, and C. Very simple. What I can do now is use Itertools.permutations to get all the possible permutations of these 3 items. So I'm using permutations function, and I'm providing it with the items, and I want all the permutations of the 3 items. And then I'm using a for loop again to print the permutation. When I run this, then this is what we get, all the possible permutations. I can also supply an extra number here. So if I, for example, supply number 2, then these are all the permutations of length 2. So when I run this, then this is what we get. As you see, it's ordered, so AB is considered a different permutation than BA. If the order doesn't matter, then you don't use permutations, but you use combinations. And now, when I run this again, you see that we get way less. We get AB, AC, and BC. And as a variety, you also have combinations with replacement. And when I run this, then this is what you get. Combinations with replacement work slightly differently because it also allows, for example, for 2 A's or 2 B's or 2 C's. There's, by the way, a simpler way to print this. You can also simply print a list made from the iterator, like so. So I can remove this for loop, and then when I run this, it's simply going to print the list of all the elements that the iterator produced. Other things you can do. Let's say I have a second list, more items. And now I can use the chain function to combine them into a single iterator. So I can print a list made from Itertools.chain, and then I'm going to provide it with items and more items. And now it's going to print all these elements in a chain. And then, of course, you can combine things. For example, I could call an Itertools.combinations on the chain of items and more items, like so. And then when I print this, then I'm going to get all the combinations, except I need to provide a number, I think. Yeah, so let's provide a number here. I want all combinations of 2. And then let's run this again. And now I'm going to get all the combinations of 2 on the chain of items and more items. And this is exactly the type of thing that Itertools allows you to do. It's an algebra that allows you to combine different iterators in different ways by chaining them or by calling other Itertools functions repeatedly on the iterator. You have to be careful though that your code remains readable. Sometimes if you combine these things in very complex ways, then it's really hard to understand. In that case, the general design principles always apply of keeping things simple. And readability is obviously very important. So in that case, it might make sense to split things up a bit more, use sensible variable names, or even create a function that groups several Itertools functions into something new and that gives that function a logical name. So a few more things I want to show you. So first, there is filter false, which is also quite useful. So what this does, it filters out the values for which some predicate is false. So if I do a print of a list Itertools filter false, and I'm going to provide it a lambda function where I'm simply going to check all the elements divisible by 2, and that column shouldn't be there. And then let's say I provide it with a range. So that's a sequence of numbers. And when I print this, you see that it prints only the odd numbers. So it's going to filter out the things for which this lambda function returns false, and then it's going to put that, in this case, in the iterator, and then put it in the list, and then I print it. There's also take while, which gets elements from the list until the function is true. So in this case, if I run this, well, the first element is 0, so it only takes the first element. If I turn this into the opposite, not equal 0, then it gets the empty list because the first element already doesn't agree to that. Another thing I want to show you is star map, which is also a very useful function. So in this case, I mentioned the example of having an iterable of tuples, so that's what you see here. And star map applies the function on each element in the tuple. So in this case, it takes an x and a y, and it's going to multiply the values. So what it will do is it goes through this iterable, takes each tuple, and then applies the function on it. So we're going to get 2 times 6, 8 times 4, and 5 times 3 when I run this. So that's what you see here. So Itertools can be pretty powerful. You can create pretty complex iterator behavior by combining these functions in different ways. And what's nice is that this is also pretty fast and memory efficient. So you don't have to worry about performance too much when you're using these Itertools functions. So question for you, are you already using these Itertools functions? And what are some of the more complex and uncommon ways in which you use them? I'll collect them, and then if there are enough examples, I might do a follow-up video where I dive into some of those non-conventional uses of Itertools functions. This was a deeper dive into Python's Iterators and Itertools package. If you like this, you might also like the deeper dive I did into the datetime package recently. I've put that video right here. Thanks for watching, and see you next week.